Hello बच्चों, how are you? Welcome to India's largest learning e-platform, Gradeup. So hello बच्चों, are you able to listen my voice? Yes or no? If my voice is okay, are you able to listen my voice? And also tell me, the video is okay? Good evening Komal, a very good evening. So guys, how are you? Tell me. Good evening Amrita. Okay, so let's everyone join the session, and guys tell me who has joined the session. Okay, mark your attendance, like the session and comment it. Good evening Swati. Good evening. Okay, fine, good. Yes, so what we have done in the last class, so if you are following my lectures, that you know that earlier we have completed the theorems, right? We have seen the so first of all we have seen the superposition theorem, then we have seen the reciprocity, then Thevenin's, Norton's, and finally we have seen the maximum power theorem. And in the last class, I gave you one question on the maximum power transfer theorem, and I told you I want answer in the comment section. But sadly, only 2 people has given the answer. Out of that, one has given the right answer. I forget the name, sorry, but the answer given by 0.5 ampere, the student was right. So does anyone solve the question? Yes or no? So first we will start our class with that particular homework question, and then we will further go for the today's topic, which is the first order circuit, or basically you can say we will start the transient analysis. This topic is going to be very useful for your GATE exam, and I will tell you a short tricks. I will tell you very many short tricks where you can easily solve the question that coming from a transient. Okay, so let's start our class. So if you are watching me first time, my name is Ishaan Mudgal. I have a 3+ year of experience. I am 5 times GATE qualified and MTech gold medalist from NIT Allahabad. These are my area of expertise, and right now we are learning a network theory. And guys, if you want a revision session on power electronics also, you can download our app and you can follow me. The link for the following me is given in the description. As well as right now I am taking a power system revision classes on app also, so that if you want to learn power system for the electrical students, you can also join me in an app. Okay, the link is given in a description. Fine, so let's start our today's class. So this particular question we have seen, I have given you this particular question, I have given you in a homework. Okay, good evening everyone. So give me the answer. Have you solved this question? Yes or no? How many of you even try this question? Okay, if you are not able to solve it, if you are not able to find out the answer, no problem. I just want to know how many of you try this question. Okay, because if you try the question, then you will see why the question is very much beautiful, or what the different concept you can think about. Okay, so what is the question actually? In this question they are asking, for what value of I the maximum power is transferred to I, and also find the maximum power transfer. So in this question they have said this is a load terminal. Let us suppose I mark it as a X, I mark it as a Y. So XY is a load terminal, and here the load connected is a current source. Very important. Here the load is nothing but a current source. So I will write here that load is current source. Now I told you very important points in case of a maximum power transfer theorem. A maximum power theorem can only be applied if a load contains a variable resistor. Okay, but here the load is a current source, so I cannot apply the maximum power transfer theorem. So I will write here maximum power transfer theorem is not applicable here. Is not applicable here. Okay, so if maximum power transfer theorem is not applicable here, then how can I solve this question? Can anyone give me the hint? Can anyone give me the hint? If maximum power theorem is not applicable here, then how can I solve this question? You have to think about very carefully. See, this is a load terminal, right? If I am able to find out voltage across current, if I am able to find out voltage across current source, means let's suppose the voltage is VL. If we find out VL, if we find out VL, then power across the load will be VL multiplied by I. Yes or no? The power across the load will be VL multiplied by I, and this power I need maximum, and this power I need to be maximum. Okay. So now the question arises, I need to find out the load voltage across the current source. Okay. And to find the load voltage across the current source, I will use the Thevenin's theorem. What I am going to use? I am going to use the Thevenin's theorem. Why I am using a Thevenin's theorem? See, using the KCL and KVL, I can also find out the voltage across it. No doubt. You can assume the current flowing in each and every branch. Apply the KCL, apply the KVL. You can find out the voltage across it, right? And then you need to find out the maximum condition. But if you follow this particular steps, like if you are following the mesh analysis, nodal or any other method, then it will take much time. So what I am doing, I am finding out the Thevenin's voltage and Thevenin resistance. So what I am going to do here, I will convert this network. I will convert this network into Thevenin's network across the current source, because right now the load is current source. So what I will do, this is a current source, so I will find out Thevenin's voltage and Thevenin resistance across the current source, and I can finally convert this particular network just in this network. I can finally convert up this particular network into this network. Okay, and after that I can find out the voltage across it. Okay, so first of all I need to find out VTH and RTH. So for VTH, what is the VTH? VTH is the open circuit voltage. So I need to open circuit the terminal. I need to open circuit this terminal. And when you open circuit the terminal, and you need to find out the VTH here. If you open circuit the terminal, bacha, then you need to find out the VTH here. So you can see this is plus minus VTH, plus minus VTH. This is 24 volt. This is 24 volt. Okay. And here I can say this is 3 ohm. This is 6 ohm. This is 4 ohm and this is 4 ohm. Can I find out the VTH easily? Yes, the answer is yes. I can find out the VTH easily. How? I have a 24 volt parallel to 3 plus 6. So I can find out the current I1 here. Similarly, I can find out the current I2 here. Why? Because I have a voltage source connected parallel to it. So I1 will be 24 divided by 3 plus 6, comes out to be 24 divided by 9 ampere. Okay, or 8 by 3 ampere, right? What will be the I2? I2 will be 24 divided by 4 plus 4, comes out to be 3 ampere, right? Now this I1 will pass through it, this I2 will pass through it, yes or no? It is plus minus, Now I can apply the KVL. In this loop. So if you apply the KVL, what you will write? Minus 6 times of I1 plus VTH plus 4 times of I2 equal to 0. And don't worry, I will come to your each and every doubt. First, I will solve this question. So VTH comes out to be 6 times of I1 minus 4 times of I2. So what is VTH? VTH will be, put the value of I1, 48 by 3 minus 12. 12 3 is 36. So 12 by 3 comes out to be 4 volt. Okay, just check the calculation. Okay, everyone, just check the calculation. If you think the calculation is wrong, tell me. So VTH comes out to be 4 volt. Now for RTH, bacha, this is a case 1. Because it does not contain any dependent sources. So it is a case 1. So for RTH, what can I do? I can redraw my network like this. Yes or no? And I need to find out the RTH from here. And don't worry, bacho, I will take your each and every doubt. Once I solve this question, I will take your doubts. So now see, if you find out RTH from here, you will see. Now, if you don't know how to find out RTH, to see my previous lectures. But here I am telling you, this is a node X, this is a node Y, this I am taking a node Z. Now from here to here, we don't have any other element. So this is also node Z. So you can see what will be the RTH. RTH will be 3 is parallel to 6 in series with 4 is parallel to 4. So 3 parallel to 6 gives me 2, 4 parallel to 4 gives me 2, it gives me 4 ohm. So RTH is 4 ohm. Now what happened? My circuit, my network is now look like this one. My network is now look like this one, that this is a 4 volt, this is the 4 ohm, this is the load terminal through which I have connected a current source. Why? Because in this question the load is a current source, right? Now I need to find out voltage across it. I need to find out the voltage across it. Let's suppose voltage I am taking at a load voltage. So what will be the load voltage? You can see, if I have a current source, the current I will flow in this direction, right? So load voltage will be 4 times of minus 4i. Yes or no? Just apply the KVL. Just apply the KVL, bachcho, and the VL comes out to be 4 minus 4i, right? Now power will be, power across the load will be load voltage multiplied by current. Power across the load is equal to load voltage. It is 4 minus 4i multiplied by current, and power across load voltage is 4i minus 4i square. Now I want this power to be maximum. For the maximum, so my friends, the maximum, for the maximum power, I need to differentiate it with respect to I. So when you differentiate it with respect to I and put it equal to 0, right? So when you differentiate it with respect to I, you will get this thing, and the current we are getting 1 by 2 ampere. It means what? To transfer the maximum power from the source to a load, the current must be 1 by 2. So that they are asking, for what value of current maximum power should transfer to I? So I की value कितनी होनी चाहिए? 1 by 2. Now they are asking, find the maximum power transfer. So the maximum power transfer will be, I have to put the value of I equal to 1 by 2, right? So 4 multiplied by 1 by 2 minus 4 multiplied by 1 by 2 whole square, it comes out to be 1 watt. This is the answer, correct? Now ask your doubts one by one. So let me see. Okay, good. Revis Danduri asking why we are not using the maximum power transfer theorem here. So listen very carefully again, beta. To apply the maximum power theorem, I gave you 2 conditions. If these 2 conditions are satisfying, then only you can apply the maximum power theorem. Which conditions? That a load contain variable resistor. First condition, the load contain variable resistor. Second, load must only contain a resistor. Means with the load, you don't have any other element connected to it. Must only contain, the load must only contain resistor. For example, if a load contain resistor with a voltage source, then again I cannot apply the maximum power theorem. So maximum power theorem can only apply if a load contain variable resistor. Keep this point in your mind always. And if there is anything, if there is any other element in a load, then I cannot apply the maximum power theorem. So here you can see this is a load. In this question, current source is a load. That's why I cannot apply the maximum power theorem here. So what should I do? I need to find out the power across it. Once you find out the power across it, then you need to differentiate it. Okay. So the power across it will be voltage multiplied by current. So what I do? I am converting this particular complex network into a Thevenin's network. Why? Because then it will be easier to find out voltage. Okay. So I find out VTH, I find out RTH, and just we have come, just this is a Thevenin's network. Okay. Now the load voltage will be 4 minus 4i. Why? Because if I have a current source connected in a branch, the same current must flow. So it will be 4 minus 4i. Fine. And finally, the load power will be VL multiplied by I. Now this power should be maximum. So my friends, for getting a maximum power, you need to differentiate the particular equation with the variable. And variable is what? Variable is current. So you can get it is 4 minus 8i. So current comes out to be 1 by 2 ampere and the power is 1 watt. Okay, so ask your doubts again. Okay, Sienna is asking, sir, how to find out RTH? Beta, see very carefully. For a RTH, you have to see this is a case 1 in which you have to short circuit the independent sources. So I have short circuit the independent sources here first. Now see here, I am giving a name to a node. These two have a name of X and Y. If I go from this node to this node, you can see I have a one element here. So this node will be different voltage. So I name it at Z. Now when you go from this particular node to this node, you will see there is no element connected to it. So name of this node is also become Z. So now see very carefully, between two nodes X and Z, I have two resistors. Between two nodes X and Z, I have two resistors. So these two comes in a parallel. Similarly, between Y and Z, I have two resistors, 4 ohm. It comes in a parallel. Okay. And both of them are in series. So 2 plus 2 comes out to be 4 ohm. Okay. Again, anyone else? Beta, if you have a load voltage, if you have a voltage connected at this load, if you have a voltage connected to this load, for example, I have connected plus minus VL like a load voltage. Okay, so everything is going to be same. Everything is going to be same. The only difference comes out in this particular step. In this particular step, what will happen? This will be a VTH. This will be a Thevenin's voltage. Okay, and now you will have some load voltage connected to it. Okay, now I can find out the current passed through it. The current is 4 minus VL divided by 4. Now what will be the power in this case? I multiply by VL. So it becomes 4 times of VL minus VL square divided by 4. And again you can follow the procedure. Okay, so if you have a load, if you have a voltage source in place of I, then you can find out the power also in this way. Okay, anyone else? How to find the VL? Beta, simple na? You can apply the KVL here. If you apply the KVL here, see what happened? Minus 4 plus 4 times of I plus VL equal to 0. So VL comes out to be 4 minus 4I. Okay, guys, fine. So I hope you understand this problem. Good evening, Karan. Okay, fine. So now we are going to start our today's topic, which is the first order circuit. So actually we are going to start a transient analysis. But before going to a question, I want to a brief introduction of a transient, and also I want to tell you the important concept you need to remember and shortcut tricks so that you can solve the question very, very easily. Okay. So first of all, a transient. What is a transient? So if you see the definition, transient is just the state in a particular network which come because of a sudden change in a network. If in a network you have a sudden change, then the transient will occur. So for a transient, two conditions must be satisfied. For a network to go in a transient, two conditions must be satisfied. The first condition, the network must have a sudden change. Now, sudden change can come in many ways. A sudden change can become in case of a switching, when we switch off and off the circuit. A sudden change can come in case of a short circuit, because whenever a short circuit occurs, it is just it occurs suddenly. It does not occur gradually. Next, a sudden change can occur in case of a step signal. In case of a step signal. Why? See very carefully. A step signal is look like this one. A step signal is look like this one. So at t equal to 0 means before t equal to 0, the signal is 0. Now suddenly at t equal to 0, it reaches a maximum value, right? So you can see here, what is happening here? A sudden change is happening. A sudden change is happening. So if you have a step signal, then also sudden change can happen, right? And next condition, storage element. Next condition, storage element. So guys, if these two conditions are satisfying in a network, then that particular network will always go in a transient. Okay, we are talking about a DC right now. So if in a DC you have a sudden change and storage element like inductor and capacitor, then your network will always go into a transient. You can never stop your network to go into a transient state. Okay, but if a network comes in a resistive form, means a network is a purely resistive, then the transient never occurs. So got this point? Next, order of a circuit. What is the meaning of an order of circuit? So order of circuit is total number of inseparable energy storage element. Total number of inseparable energy storage element is known as the order of a network. So order of a network tells you how many energy storage element in your circuit have. For example, if I say the circuit is a first order, so it means your circuit will have either an inductor or a capacitor. If I'm saying the order is second order, so your circuit will have either inductor and capacitor pair or two inductors or two capacitor. Okay, and for your course you are not getting a higher order circuit. It means in your course you have only first order and a second order. Fine. Now what is the meaning of inseparable means? For example, let's see this particular diagram. Now everyone tell me what will be the order of this diagram. Everyone tell me the order of this diagram. Everyone. Okay, everyone, what will be the order of this diagram? Okay, give me the answer. Okay, everyone, all the people should give the answer, and guys, like the session, because if you like the session, that will be your attendance. Okay, everyone give the answer. Okay, and try to spread these lessons everywhere in your study chat, in your study group, in your WhatsApp group, so that they can also beneficial from this. Okay, so tell me the order of a network here. See, now some people can say the order is 3, right? But is the order 3? For example, Ravi has said the order is 3, right? Okay, 3, 1, 2. I am getting a number of answers here. Okay, but see, what is the order? What I can do? See very carefully. Can I combine these 3 inductors? Yes or no? Can I combine these 3 inductors? Kaise? 4 ohm and 2 ohm are in parallel. So 4 parallel to 2 give me what? 4 2 divided by 4 plus 2 6. So will give me 4 by 3 Henry. Now 4 by 3 which are parallel to it is in series with 2 Henry. So 4 by 3 plus 2 give me 10 Henry. 10 by 3 Henry. So what can I do? I can replace these 3 inductor with a single inductor. I can replace these 3 inductor with a single inductor. So it is not a third order or second order. This is the first order network. This is a first order network. Remember this point. Inseparable means क्या होता है कि आप उसे separate नहीं कर सकते हो. तो आप देखो, I can combine these 3 inductor together. If I combine these 3 inductor together, it means what? It becomes 10 by 3 Henry. For example, I have a 6 Henry inductor. Okay, if I am representing this inductor like this, 4 Henry, 2 Henry, it doesn't mean these are the 2 inductors. It's actually a 1 inductor. I can combine it. So always remember, when you write the order of a network, you have to see, can you combine the energy storage element? If you combine the energy storage element, then combine it, and after that you have to write the order. So this is the first order circuit. Fine. But if the circuit is like this, let us suppose the circuit is like this. So here you can see I have 2 inductors. I cannot combine them. So this have a second order circuit. So this is a second order circuit because I cannot combine 2 inductors here. Fine. Next. What is the meaning of time constant? Very important thing. What is the meaning of time constant? So beta, time constant का मतलब क्या होता है? So many definitions you have heard earlier, you have seen in many books. Okay, so I will tell you the definition. Okay, Sheikh is asking, sir, if there is a capacitor of, Sheikh is asking, sir, if there is a capacitor will be in a second order. No, beta, if in place of a 4 Henry means if you place a 4 Henry capacitor here, right? If I place a 4 Henry capacitor here, then you can see you cannot combine this 2 Henry and this 2 Henry. Then the order will be 3 because of 2 inductors and 1 capacitor. Because if you place the capacitor in place of a 4 Henry, then I cannot combine these 2 inductors. Okay, then the order will be 3. Now, time constant, you have seen the definition many in different books. Okay, here I will tell you what is the time constant according to two conditions, a charging and a discharging condition. So here I am discussing you about a charging and discharging. Now, charging and discharging can only happen if your network contain an energy storage element. Obviously, if your network doesn't have an energy storage element, then how will you give the charging energy, or how can you discharge the energy from it? Okay, so what is the time constant? First of all, I am talking about a charging circuit. In a charging circuit, you know the initial energy will be 0 and the final energy will be some value. That is meaning of charging circuit. So in a charging circuit, the time to reach 63% of final value, time to reach 63% of final value is called time constant. So the time which a circuit is taking to reach the 63% of final value is known as the time constant in case of a charging circuit. In case of a discharging circuit, what will be the time constant? In case of discharging circuit, time to reach 37% of initial value. 37% of initial value is called time constant. Okay, and time constant is represented by symbol tau. Now, time constant is very important because in almost 80% question you have to find out the time constant. The question from directly you have to find time constant will never come. Sometime rarely it has come 1 or 2 times, but in almost all the questions, or you can say 80% question, we have to find out the time constant of a circuit. That's why this is very important part for the transient. So here I told you 2 circuits, charging and beta discharging. So I will create 2 graph of charging and discharging here to understand this point. Let's suppose I am talking about the voltage right now. Voltage with respect to time and voltage with respect to time. This is time t, this is time t. Okay, beta. So first of all, charging. Charging means it will start from 0 and reach to some final value. Let us suppose this is the final value of the voltage V final. Now, in case of a charging, the time to reach the 63% of final value, the time to reach the 63% of final value will give you the time constant tau. Similarly, in a discharging, what happened? The time to reach the, this is the initial value, let's suppose, okay, the time to reach the 37% of initial value is the time constant. Okay, and one thing you need to show very carefully, whenever you have a charging or discharging, whenever you will have to see the exponential term in a circuit. Always exponential term in a circuit come because of the resistor. So always remember one point, in case of a transient, if you have to find out the voltage or a current equation and your circuit contain a resistor or a bunch of resistor, then you will always get an exponential term, because this exponential term is the responsible for charging and discharging, or you can say the graph of the charging and discharging comes in an exponential form. Okay, so now the question arises how to find time constant. Now the question arises how to find the time constant tau. Okay, so I told you in case of in 80% question we need to find out the time constant. So beta, what happen in case of a time constant? First of all, first order circuit. How to find the time constant of a first order circuit? So in a first order circuit, either you contain a circuit contain inductor or a capacitor. So in case of an inductor, the time constant is L by R. In case of a capacitor, the time constant is R multiplied by C. And actually write the R equivalent. Write the R equivalent. Okay. So in a first order circuit, you will have inductor. So the time constant will be this. If you have a capacitor, time constant will be this. Now the question arises, how to find the R equivalent. To find the R equivalent, what we have to do? First of all, remove the independent element. First of all, remove independent element. Okay, independent source को remove करना है. Second, find R equivalent from capacitor terminal. From energy storage terminal. From energy storage terminal means if you contain an inductor or a capacitor, I need to find out the R equivalent from the energy storage terminal. Okay, what does it mean? Just I will take one example here. To give you understanding of this concept. Let's suppose I have a resistance like this. I am drawing one simple circuit. Here. Okay, this is 2 ohm, this is 2 ohm, this is 4 ohm. Let's suppose this is 6 ohm, this is 5 ohm, this is 2 farad, 2 ampere and 2 volt. Now the question is find time constant tau. Okay. So see here very carefully. This formula can only use for the first order circuit. So you can see the whole network contains single capacitance. So this is the first order circuit. So first you have to make sure what is the order of a circuit. Now for a time constant, I need R equivalent and a C. C I know is how much? 2 farad. I need to find out the R equivalent. So I told you, first you have to remove the independent element. Remove the independent element means voltage source short circuit, current source open circuit. Simple. So what will happen here? This will be short circuit. This will be short circuit. This will be open circuit like this. And this is the capacitor like here. And I have, and 2 plus 2, they are in series now. I can combine them and make it a 4 ohm. This is 6 ohm. This is a 5 ohm. This is a 4 ohm. Okay. Now second point is very, very important. We need to find out R equivalent from the energy storage terminal. Now energy storage is here. So I need to find out R equivalent while seeing from this side. I need to find out R equivalent from this side. So when you see your network from this side, you will see 4 ohm and 4 ohm are in parallel. Because this is open, so no current will flow through 5 ohm, right? And 6 ohm are in series. So what will be the resistance? R equivalent will be 4 ohm is parallel to 4 ohm plus this 6 ohm is in series. So it comes out to be 8 ohm. So time constant will be R equivalent multiplied by C equal to 8 multiplied by 2, 16 second. 16 second. Okay. Fine. Now any doubt here? Anyone? Any doubt here? Okay. Do you get it? Tell me everyone, do you get it how to find out the time constant in case of a first order circuit? Yes or no? I need answer from each one of you. Do you get it how to find out the time constant in the first order circuit? Fine. Now in your exam, you need to find out time constant only for the first order circuit. They will never give you to find out the time constant for the higher order circuit. But let's suppose they give you. So for the higher order circuits, or you can say second order circuit also, for the higher order circuit, the time constant tau is equal to reciprocal of the real part of dominant pole. Okay, so in the history of GATE, they never ask you this particular thing, but in different exam they can ask you to just you can remember this point. what is the time constant actually? Okay, what is the time constant? That you need to find out the characteristic equation. Remember the control system. Need to find out the characteristic equation. Then denominator of the transfer function is what? The characteristic equation. From there I can find out the pole. Then the pole which is nearest to the origin. The pole which is nearest to the origin known as the dominant pole. Then the real part, reciprocal of the real part of a dominant pole is the time constant. Okay, so you will not get this particular statement in many books. Okay, but you can remember this. Now Sheikh is saying once again, beta Sheikh, if you have problem in this question, see this video again. But I will explain briefly what I have done here. I told you I need to find out the R equivalent. So R equivalent is similarly R equivalent. To find out R equivalent, the same thing you have to use the Thevenin resistance. In a Thevenin resistance also, what we have done, we have short circuit the voltage source, open circuit the current source, right? But in here, one thing you need to remember, that the terminal from where you need to calculate R equivalent, that will be the energy storage terminal. Means I have to see from the capacitor and then I have to calculate the R equivalent. So when I see from the capacitor, you can see 4 ohm and 4 ohm are in parallel, and these two are parallel and series with 6 ohm. And because the 5 ohm resistor is open, so I will not include this 5 ohm resistor in our calculation. So 4 ohm and 4 ohm are parallel and with the series, so the resultant comes out to be 8 ohm. Okay, Sheikh? Fine. Okay, so now I want to discuss with you what happened. See, transient occur because of the energy storage element, right? Transient occur because of the energy storage element, and what happened? The energy storage element will behave differently. An energy storage element will behave differently at different time instant. That's why a transient occur. What this statement means? So first of all, see the timing diagram. First of all, see the timing diagram. And don't worry, bacha, if today we are not getting time to solve the question, we can solve the question in next class also. But learning a concept is more important. Learning a concept is more important. That's why I'm telling you concept first. But again, I'm telling you concept and briefly. I'm not explaining you to a deep level. So see here, what is the timing diagram? T equal to 0. This is the instant. This is the time axis. This is the instant of 0. T equal to 0 is the instant of switching. Means it is the instant at which I will switch on or switch off the circuit. Okay, a circuit must contain a switch like this, because I told you a transient will always occur if there is a sudden change. So T equal to 0 is the instant at which the switch is on or the switch is off. Anything can happen. Now T equal to 0 plus, it means just after a switching. Just after a switching. This is T equal to 0 plus. Now T equal to 0 minus is just before the switching. And these two are very, very important. 0 plus is just after switching. Just after switching. And 0 minus just before switching. Okay. Just before switching. Now we have one more time. Steady state settling time, TS. TS is the settling time. Settling time is the time where transient end. Settling time is the time when the transient end, because there will be a time now when transient will die out and your steady state will start. So this is the time, settling time. This is the time at which transient end, or you can say it is a time to reach the steady state also. Because after a transient, which state will come? Steady state. So from here to here, I have a transient state. From here to here, I have a transient state. Now from here to till t tends to infinity. From here to till t tends to infinity, I have a steady state. Now one more important point. Before switching, if I come from infinity, it is also a steady state. It is also a steady state. So remember, this timing diagram is very important. before the switching we have a steady state, and then at t equal to 0 to t equal to ts, which is the settling time, we have a transient state, and after settling time I have a steady state. Okay, got my point? Yes or no? Right? Now what happened? These three times are very important. These three times are very important. This 0 minus, this 0 plus, and this infinite. These three times are very important. A inductor and capacitor behave differently in these three times. So what I need to do? I need to remember how does this particular inductor and capacitor behave. Okay, we don't go into a derivation, because in the end I have to remember the results. So I will discuss the result with you. So here I am giving you a time instance. Here I am discussing a time instance. Here I will discuss about a inductor, and here I will discuss about the capacitor. Now beta, first of all, first thing you need to remember is the property of inductor and the property of a capacitor. The first and most important property of inductor is that through inductor, a current cannot change instantaneously. Remember this point. Through inductor, current does not change instantaneously, and through capacitor, voltage does not change instantaneously. What does it mean? It means if through an inductor 2 ampere current is flowing, then you cannot suddenly change the current of that inductor. For example, if I am saying at t equal to 0, 4 ampere current is flowing through an inductor. 0 minus means before switching. Okay. Then if I talk about t equal to 0 plus, then again through inductor the current will be 4 ampere, because the difference between time is very less. So this thing you need to remember. This is the property of inductor, that current through it does not change instantaneously. Similarly, voltage across capacitor does not change instantaneously. Okay, these two are very important points, and almost in every question we have to use this two particular result. Next, if I talk about t equal to 0 plus, see what happens in a t equal to 0 plus. Inductor behave like a current source. Inductor behave like a current source, and the magnitude of current source will be IL 0 plus. Very important. At t equal to 0 plus, inductor behave like a current source. And what is IL 0 plus actually? It is the initial current. It is the initial current passed through inductor. Similarly, VC 0 plus is the initial voltage. It is the initial voltage stored across capacitor. Okay, fine. So initially at t equal to 0 plus, inductor behave like a current source, and at t equal to 0 plus, capacitor behave like a voltage source. Capacitor behave like a voltage source, and the initial value is VC 0 plus. Very important. Very important. The initial value will be VC 0 plus. Now what happened? If IL 0 plus is 0, means inductor is not charged initially. If in the question it is mentioned inductor is not charged initially, or they have mentioned the inductor current is 0, then what happened? So think about yourself. If the magnitude of a current source is 0, then that particular current source will act like an open circuit. Yes or no? If the magnitude of a current source becomes 0, then that particular inductor will act like open circuit. Similarly, if capacitor is not charged initially, means the initial capacitor is discharged. So in that case, what happen? The capacitor will act like a short circuit. Why? Because when VC 0 plus will be 0, it means voltage source is 0. Now voltage source is 0 means short circuit. Okay, very important. Almost every question you have to use this particular thing. So this will happen at t equal to 0 plus. Now if I talk about t equal to infinity, or I am talking about t equal to 0 minus, in both the case this is a steady state value. Means if I talk about a steady state, so what happen? Inductor will act like a short circuit. Always, whenever you are seeing the 0 minus, or whenever you have to draw the circuit at infinity, always remember inductor will change into a short circuit and capacitor will change into a open circuit always. Because t equal to infinity or 0 minus is a steady state, and at a steady state capacitor does not allow DC to pass. So if the capacitor does not allow DC to pass, so it will act like an open circuit, but inductor will allow DC to pass, that's why it will act like a short circuit. Now the final line, if I'm talking about the time, between 0 to TS, it means which time I'm talking about. See very carefully, I'm talking about this time, transient state time. If I'm talking about 0 to TS, so beta, in this time I have to use the Laplace transformation. Here I have to use the Laplace transformation, but I will tell you one shortcut trick so that I will not go into a Laplace transform. So what happened in this case? Inductor will change into a Laplace form SL in series with a voltage such that the magnitude of voltage is LIL 0 plus. The magnitude of voltage is LIL 0 plus. So let me write again. The magnitude of voltage will be LIL 0 plus. And see one point very carefully. The polarity of a voltage source. It is opposite to the current flows. Flowing. So current is flowing. It will enter into a negative terminal of a voltage. Next, what happened to a capacitor? Capacitor change into a Laplace form 1 divided by SC, and here the polarity of a voltage source will change, and here the magnitude is VC0 plus by Vs. Okay, so this table is going to be important. So first thing you need to remember is this table. What happened to a different inductor and capacitor? What happened to capacitor and inductor at different time instants? That will come from this table. And the important rows or column in this table is this particular row is very important. Okay, we are not using this. We will not use this row. I will tell you one shortcut trick where I can skip this particular row, but these two rows are very important. So again, if you have any doubt, so you can ask. Yes, that I have said, Ravi, that I have said you that at IL 0 plus and IL 0 minus, the current will be same. Means at t equal to 0 plus and t equal to 0 minus, current through inductor will be same. Similarly, the same properties goes for the capacitor voltage. Okay, guys. Now what happened? I will tell you one shortcut formula. So first I will tell you one shortcut formula, and then I will tell you the limitation for this formula. So the shortcut formula is this: voltage across any branch, any element, voltage across any element Vt is equal to V infinity minus V0 plus e raised to power minus t by tau. See what happened. Why this is a shortcut formula? If someone asks you to find out the voltage and current equation with respect to time, then I have to use the Laplace transformation. So Laplace transformation is easy, but the inverse Laplace will be difficult task, because if the network become complex, then inverse Laplace become difficult. Okay, so for that I can use this particular formula. And why it is useful? Because I need to calculate only three things. For example, I will draw my circuit at t tends to infinity and calculate the voltage. I will draw my circuit at t equal to 0 plus and calculate the voltage, and I need to calculate the time constant. And these three things are very much easier to find as compared to Laplace transform. Okay, got this point? Yes or no? Why this formula is important? So this formula is important, bacha, because this will prevent me to go into a Laplace transformation. Okay, one student is asking, why do we use Laplace rather than Z? So Dindi, beta, Laplace is used for the time domain and Z transform is used for the discrete domain. But right now we are not discussing a discrete domain, we are discussing only the time domain analysis. Okay, if we discuss the discrete domain analysis, then we have to use the Z transformation. Similarly, if I want to find out the current through any element, if I want to find out current through any element, then again it will be simple. Again, the formula is same, just you need to replace current voltage with a current, like this, simple. Okay, so for a voltage and current, I can use this particular formula. Now, what is the limitation for this formula? This is very important. Understanding the limitation is very important. The first limitation is that this formula can only be used, in first order circuit. This can only use in a first order circuit. I cannot use this formula in a second order circuit. But one thing is very beautiful, that if you see the previous year question in the last 30 years, only 3 times the second order question has been asked. Okay, so this is very much useful for us, because most of the time, if they are asking you the voltage equation or a current equation, then you have to use the shortcut method. It will be very less amount of chances that they will ask the question of voltage or current for the second order circuit. Second limitation, this can only use for step signal. This can only use for step signal. So if your signal is a exponential signal, or if your signal is a ramp signal or any other signal, then I cannot use this particular equations. This particular equation can be used only for the step signal. For example, if the voltage source is 5 volt, 6 volt, I can use this particular equation. But if the voltage source is like this, e raised to power 80, then I cannot use this particular equation. Remember this point. Okay, very much important. Now, in the end, the last thing I will tell you the flow chart, how to solve the question, and then we will jump to the questions. Okay, so the time is not enough right now to jump to a question. So just I will tell you how to solve the question. Then from the next class, I will solve. From the next class, we will solve the questions of both first order and second order circuit. Now, how to solve the question? I will give you one flow chart, and then I will tell you what you need to remember for the transient. How to solve the question? So for any question of transient, don't see what they are asking. Don't see what they are asking or what they are not asking, or what is the order. If you have any question of a transient, the first step, any question of transient, step first, for any question of a transient, if you have any question of a transient, the first step is to find inductor current at 0 minus and capacitor voltage at 0 minus. Always remember, first of all, I need to find out inductor current at 0 minus and voltage across capacitor at 0 minus. Why? Because I know if I am able to find out these two things, then inductor current at 0 plus will be equal to IL 0 minus, and capacitor voltage at 0 plus will be equal to capacitor voltage at 0 minus. Now, how to find out these two things? You just need to draw your diagram at t equal to 0 minus, and when you draw your diagram at t equal to 0 minus, you have to use this particular table. Okay, fine. After this, the question can be asked in 2 ways. After going to this, question can be asked in 2 ways. Means if the question is asking at t equal to 0 plus, if question is asking anything at t equal to 0 plus, they can ask you a voltage, they can ask you a current, they can ask you the change in voltage, they can ask you the change in current. So whatever they are asking, if they are asking at t equal to 0 plus, so what I will do, I will draw the circuit. I will draw the circuit at t equal to 0 plus and find the output. Okay. Now, if they are not asking anything at a t equal to 0 plus, if they are asking for any general time, they are asking. For any general time they are asking, for example, they are asking you the equation of current, they are asking you the equation of voltage, or they are asking you what will be the current at t equal to 4 seconds, what will be the voltage at t equal to 6 seconds for any general time rather than 0 plus. Whatever they are asking, first you have to check whether the circuit is of first order or a second order. So for first order circuit, I can use the shortcut formula. For first order circuit, use shortcut formula. For second order circuit, use the Laplace transform. Okay, but there is very less chance that they will ask question from this particular concept. Okay, so what you need to remember? You need to remember the flow chart, which means this, how to solve the question. Then you need to remember this shortcut formula, and finally you need to remember this table. These three things you need to remember. What three things? A flow chart, a table, and shortcut formula. If you remember these three things, then 95% of your question will be solved for the transient chapter. Okay, because 5% questions are different, that require different strategy, but 95% question will be solved if you remember these three concepts. Got my point? So you will understand all of these things when we go to our questions. Okay, so if you have any doubt right now, ask me. So Ravi is asking beta, how to find other than step signal, that I will explain you through the questions. Okay, Sheikh? So Ravi is asking, sir, my doubt is t is equal to 0 plus and 0 minus, inductor has same current. So why choose 0 minus steady state? Ravi, 0 minus is a steady state because you can see you are not providing any disturbance at 0 minus. Disturbance will be provided at t equal to 0 plus. Disturbance is provided only at t equal to 0. Before t equal to 0, there is no disturbance. And if you are not creating any disturbance, then your circuit is at the steady state. For example, in your home, when you switch on the AC, first thing what happen? A fluctuation will happen. Okay, before turning on the AC, your whole system of the home is in a steady state. There is no disturbance, but you are adding the high amount of load in terms of AC in your home. So what happened? You are adding a load suddenly in your network. Then what happened? The switching will happen, due to which a transient occur. And due to a transient, you see the voltage fluctuation every time when you switch on the AC. Okay, but that voltage fluctuation will never happen in case of a fan or a tube light, because turning on fan and tube light is a gradual process. Okay, that's why before t equal to 0, when there is no switching, this particular state is a steady state, which is the state of equilibrium. At the transient state, the energy transfer will take place. Okay, now anyone else? So Aditi is asking, sir, how do we know that circuit belongs to a first or a second order? Aditi, beta, I just explained this concept half an hour ago. How will you get to know that circuit is first order or second order? I guess you didn't attend the class from 9 p.m. right? So beta, for a first order circuit, network will contain either inductor or capacitor. Okay, for the second order circuit, a network can contain a pair of inductor capacitor, or the pair of two inductors, or the pair of two capacitors. So in this way, you can identify whether a network is of first order or a second order. But watch my lecture from the starting, then you can able to identify it. Okay, I explained these points half an hour ago. Okay, guys. Okay, so we will do the question tomorrow. Don't worry. Today we just understand the concept. Don't worry. We will learn the question tomorrow, and tomorrow we are going to solve first 2 or 3 basic problem, then medium problem, and then advanced problem. Okay, so all of these problems we are going to solve, and you will see every problem that we are going to solve will be used these 3 things: flowchart, table, and shortcut formula. So this is very good. If you remember these 3 things, 95% of your questions of transient will solve easily. Otherwise, if you see some books or something else, you will get confused that how they are finding out values and why they are finding out these values. Okay. Beta, there is not any notification available for the IRMS. So last notification was come in month of May, I guess. So there was not any new notification for the IRMS. So this year, if you're talking about 21, so I cannot say very sure because it will be told by the UPSC. I guess they will provide you notification in January. Okay, but if the IRMS happen, it will happen in a month of August or September, because as you know, June, in a month of July, sorry, we have a IES exam. Okay, so in a month of August and September, if exam happen, it will happen in those months only, not before the July. Okay, that I am guessing, but everything will be in the hand of a UPSC, so we will have to wait for their notification. Okay guys, so we will meet tomorrow, same timing, 9 p.m. Don't miss the lecture and try to share your lecture in every group, every of your WhatsApp group, so that they can learn the things and they can ask the doubts that you are not able to think about. Okay, so we will meet tomorrow, same time, 9 p.m. Important lecture hone wala hai, because we are going to discuss the question on a transient, including first order and the second order. Okay, so bye bye guys, take care, good night.